Yeah, hackathon. You get together with a bunch of your friends, and then you try to like implement a really fancy app, and then, well, not necessarily algorithmically fancy, but fancy on the outside, and then pitch it to some judges, right? That's not what competitive programming is about. Competitive programming is about solving challenging problems, challenging computer science problems. Normally, you would have 2 to 3 hours, or like 2 to 4 hours to work on a couple of challenging and interesting algorithmic problems. Generally speaking, competitive programming contests focus more on problem solving than software engineering. So this quarter, we're hosting our the beginner track, where you can find out what competitive programming is about. We're gonna go over some basic but interesting topics such as arrays, sorting. Wait, I don't know. Arrays, sorting, binary search, and dynamic programming, and graphs. If you don't know what these are right now, it's totally fine. We'll start from the beginning so that you don't need prior competitive programming experience. And if you have any questions, if there's anything unclear in our presentations, definitely feel free to maybe like raise your hand and then ask the question. If you don't want to ask the question right now, we encourage you to ask us the questions like in the Discord channel or afterwards towards one of the officers. We have all the officers' pictures right here, and then the officers stand up just so that people know you. Okay. So yeah, and the time of our workshop will be Wednesday from 6 to 8 every week, and the location I think should be here, but there might be update. So just keep your eyes out for that. Okay, so here's your journey potentially in competitive programming at UCLA. Starting from this quarter, you can attend our beginner track, and then next quarter we'll have an intermediate track, which will go into more topics. Well, yeah, more topics, and we'll go into those topics more in depth. And then after next quarter, there will be, so in spring, there will be Code Sprint LA. That is a UCLA like ACM hosted, ICPC hosted coding contest where you can get together with some of your friends and then solve algorithmic problems together. It's gonna be really fun. It's a lot of fun for us to make the contest every year, and it's a lot of fun for the participants each year too. Last year we had like around 400 participants, and then we gave out $2,000 in prize. So if you think that sounds fun to you, definitely keep an eye out during the spring quarter, and then we'll give out more information then. And then after the spring quarter, perhaps in your second year, your third year, you could try out for the ICPC team. The ICPC stands for, oh yeah, I haven't mentioned that yet. The ICPC stands for International Collegiate Programming Contest. And it's a really big contest, competitive programming contest that universities from all over the world participate. And then they always go in groups of 3. You start from, for example, at UCLA, originally we formed 5 groups of 3 people, and then the top 2 teams advance to the next level. The 5 teams go to the regional contest, right? And then the top 2 teams, if they perform well, they can advance to the next level, which is called divisional, where you compete against people like universities around California and some other states. And then after divisional, if you perform well, you can advance to the next stage, which is called national. Only one team from each school can advance to that level, though. But yeah, if you do really well in the national contest, you get a chance to go to the world finals. the UCLA team had some really insane people this year. So our first team got the chance to go to World Final this year, which is in Bangladesh, and it's gonna be really fun for them. If you are interested in doing ICPC contest and then joining the UCLA team, we have a tryout this Saturday, 12 to 3 in Engineering 6-89. So we'll have more updates on that in the Discord channel and as well as Facebook. So if you want more information about that, you can check out the Discord channel. Also, during spring, there will be an advanced track. In the advanced track, we'll be talking about a lot of really advanced stuff. Some of the data structures and algorithms I'm not even very familiar with, so I won't be talking about it, of course. But it's really challenging, and it comes up a lot in some of the more advanced contests, like, for example, the ICPC World Final. And then other than that, you can also participate in some contests hosted by third parties like Google Code Jam and some other contests. For example, I know that if you perform really well on the Google Code Jam, you can get an internship, no, not internship, an interview from Google. Not that easy to get into Google, I know. Right, and just in general, after participating in our workshops, right, coming to our workshops, learning about algorithms and problem solving, I can assure you that you will become a better programmer and a better problem solver in general, because a lot of the techniques we use here are applicable to, for example, your coding interview, right? For example, your assignments in your courses. So we hope that we can help you to become better and improve your, and then become a better problem solver. Okay, so why do you want to participate in competitive programming? First of all, as an officer at ACM ICPC, I find it fun. And I believe a lot of people at ICPC or in ACM in general think it's fun. You get to hang out with your friends a lot, and then you get to work on some interesting problems, think about problems that you've never seen inside your class, inside the classroom, and then it's also useful because you get to practice writing code that are like, it's useful because like once you're practiced in your skilled in competitive programming, you would find coding interview questions not as hard anymore because the skills, the techniques, the thinking is very transferable. And then thirdly, the social aspect. If you, for example, you guys are all here at the workshop, and then you get to make a lot of friends, hopefully, and then you get to meet new people. And furthermore, if you want to participate in ACM, like really join ACM, become an officer, right, and then work on like workshops with us, I think the internship program, ACM internship programming, is opening soon, where we'll recruit a lot of people so that ACM can provide the quality content to the entire CS and non-CS community alike. Right, and then finally, if you want to, competitive programming can provide you with the competition and the glory, right? For example, at the beginning, you might not know anything. You might be a newbie. And then as you practice more and more, eventually, you can become a galaxy brain legendary grandmaster on code forces. I don't know if you guys play chess. If you're like me, who started playing chess since the Queen's Gambit, then it might be too late for you to become a grandmaster in chess. But it's not too late to become a grandmaster in competitive programming. Oh yeah, and also it's an esport. Here's a screenshot of coding contest, a stream of a coding contest on Twitch. As you can see, there are 2,000 people watching it concurrently. That's pretty impressive. So in the stream, basically a bunch of legendary grandmasters, so like galaxy brain coders, got together and then just try to beat each other in programming. Now, there are a lot of programming contests to participate in if you are interested. First of all, there's the ICPC regionals or like ICPC tryout this Saturday. And there's also the Code Sprint in LA, as I mentioned. It's going to happen in spring. Also, Code Forces is a really, really useful website if you're interested in doing more contests. They host multiple contests per week. And if you perform well on that website, you get rated, and eventually that's the way you become a grandmaster in competitive programming. And other than that, there are also other websites such as TopCoder, CodeChef, AdCoder, HackerRank, so on and so forth. These are all really good online resources for you to practice competitive programming. Okay, now enough of that. Let's get into coding, right? Before we get to look at the problem, before we get to solve a problem, well, I guess I want to mention the importance of using a pencil and a piece of paper, because the problems in competitive programming are very, how should I say it, complex in general. You want to use a piece of paper and a pencil to sort out your thought before you start coding. It will save your time. It will save you a significant amount of time during a contest. And then we also recommend you to use C++ for command programming because of these reasons. First of all, C++ is a very fast language. Unless you want to code in C or even assembly or machine code, unless you are that galaxy brain, we recommend you to use C++. And then it's also the language of instruction for UCLA. For example, you learn C++ in CS31 and 32, maybe some operatives, I'm not sure. So yeah, we use C++ in this workshop so that we don't have to cover the syntax and stuff like that. And also C++ contains a huge standard library that contains a lot of code, a lot of data structures and algorithms that are very useful in competitive programming. There are also other alternatives if you'd like. For example, Java, Python. Most of the platforms I mentioned before, competitive programming platform I mentioned before, accept solutions in these languages. So you can use them without worrying about it. But we still recommend you to use C++. Now, just by show of hands, how many of you already have an editor compiler set up on your computer? Okay, so that's, I think, most of you. Has anyone not had this set up? Okay, if you don't have this set up, I recommend you to have it set up like soon for your CS courses and also for all the ACM workshops. But for today, oh yeah, we recommend you to use like one of these text editors. For example, VS Code is really good. I've heard also Sublime Text add-in, also Xcode if you are using a Mac. Right, and then any of these operating systems work. Apple, Windows, Linux, Ubuntu, which is technically also Linux. And then we use the G++ compiler normally. Yes?
The competitions have a list of compilers that are pre-installed on the computers, right? Like when you go to regionals.
Yeah, you can choose what compiler.
Because they don't have, do they have VS Code?
VS Code is a text editor,
Yeah.
so it's not the compiler.
Yeah, I know it's not the compiler, but because when you go to the competition, you use their computers, yeah?
Yeah.
And they only have like a set of pre-installed IDEs. They have like Xcode, Lion, stuff like that.
I'm not too sure.
Oh, okay.
Because last year the region was online, and that's the only one I attended. Yeah. Anyway, if you don't have a setup yet, anything set up yet, we recommend you to use repo.it for today. It's a really, really not really fast. It's a really convenient online text editor. You can just go on there. For example, let me do a demo. I think, okay. So this is what their website looks like once you log in. And then you can click on create repo, select the language. I'll pick C++. And then, well, the title doesn't matter. And then we create a repo. Basically, this creates a workspace for you to code in, right? On the left side, you can see all the files in this workspace. And then in the middle, that's where you can code, type in your code. In this case, there's include IOStream, int main, standard cout, hello world. It's a very basic hello world program. And then once you finish coding your solution in the text editor, you can click on run. And then this, the output of the program will show up on the right side. It basically simulates a traditional text editor environment on your local computer. Okay. So that is repo.it. Right. And then for the purpose of this workshop, we'll be using Kattis as our coding platform. It's like Codeforces, but it's more beginner friendly, and it helps us. It allows us to post content on there without doing too much work. It's more convenient for us as well. Yeah. So now, if you want to create a Kattis account, you can go to this link, open.kattis.com/register, and then on the website you can register for an account and then join us during our workshop to work through some examples and then some contest problems. I'll give you guys like 3 minutes to do that maybe, and then once you finish registering, tell us your username so we can know who you are, and then we can perhaps provide you with some prize once we notice that you come to our workshop a lot.
Oh. Did you already start? Yeah, that's true. Fresh. Yeah, they did.
So basically, I do the exact same. I do the exact same. The only difference is
I have like a difficult How did I go? Me and Margaret,
yeah. Yes, yeah.
I just like was brought to this page when I logged in.
I guess so.
Do you guys still need more time? Could you
Raise your hand if you still need more time. Someone done? Oh, okay.
Okay. We'll give you 1 more minute, and then we will continue.
Oh, okay. We're just.
Oh yeah, can you guys at the back see the link? Okay, I'll continue with the workshop. I guess you can fill out the form anytime you want. So here's what a typical problem looks like on Kattis. At the top, you have the title of the problem, and then follows it, there's a problem statement where they'll tell you the background of the problem and why this problem might be of interest to you as a computer scientist. And then follow up, there's the input specification and the output specification. These sections are really, really important as they tell you exactly how you want to take your input and output, and then how you want to print out your output. And then finally, at the bottom of the page, there's always a sample test case section where they give you a couple of sample test cases for you to run through it, for you to work through by yourself before you submit your solution. And then at the top right corner, as you can see, there's a submit button. You can click on the submit button to submit your code once you finish coding it. And there are also some other useful information. For example, the CPU time limit, it tells you how long your code can run for before they cut off your program and then call it too slow. It also tells you the memory limit, so how much memory you can use in your program. So once you click on the submit button, it will lead you to this page where you have 2 ways of submitting your program. First of all, you should select your language. For example, if you want to use C++, then just select C++ in this window, in this drop-down window. And then afterwards, you can click on switch to editor and then copy paste your code in the editor. Or you can just drag and drop the file in the window above here, up here. And then you click on submit. It should lead you to, wait, actually, what? Okay, yeah. And then you just click on the submit button. It should submit your solution. Just so that you guys can get some practice in, here's the link to a contest with 3 problems. And then if you go to this link and then click on the first problem, it should be a pretty easy problem. And I'll give you guys like 2 minutes to try and solve this problem and submit the problem. The link is tinyurl.com/fall21-ICPC-examples1. It's pretty long, so I recommend you to click on it on the slide. Oh yeah, you need to join the contest before you can submit the problem. Wait, yeah, can you not? Yes. Okay. If you have trouble going into the contest, I'll do a little demo over here. I think I can join the contest. You click on standings, and then at the top right corner, there should be a join the contest button. And then you can just click on it, and then you'll become a participant.
Oh.
Let me switch. Not yet. Not yet. Oh yeah. If you submit it to the first problem called Hello World, you can maybe just come back to the workshop now. If you haven't submitted it, I guess you can leave that for later. If you have problems submitting to the problems, we can help you later on. Right. Okay. So hopefully you've reached a page like this after submitting your solution. On the left, it tells you the ID of your submission, the date of submission, and then the problem name, the status of your submission. Right? Hopefully, you got a green check mark and then an accepted text. But if not, then it means your program has a problem. And then at the bottom, you see these little boxes with check marks. They tell you how many test cases your solution passed and how many test cases your solution failed on. In order to be considered, in order for your submission to be considered correct, you have to pass all the hidden test cases, not just the sample test cases, but all the hidden test cases. And unfortunately, you don't get to see them in competitive programming contests. So you have to figure out the other test cases yourself. Okay. So these are some possible outcomes after you submit your program. Your program might be accepted, which means nice, your program is good, right? And then it also might tell you your program is wrong. And then it could also be time limit exceeded, which means your program is not efficient enough. It may or may not be correct, but it's not fast enough. So the online judge just cut off your program's execution. It might also be compiler error, runtime error, and so on and so forth. You can always come back to this page to take a look if you are not sure what the error message is. And then you might wonder, why am I getting a wrong answer, even though my program might look correct? So one key issue in competitive programming is that your solution must follow this output specification strictly, which means there's no extra spaces between words. You have to have correct capitalizations. There must be no extra empty lines in the middle, and you have to correctly run your numbers. Another thing is that every program you submit on a competitive programming website has to be a complete program. For example, many of you might be familiar with LeetCode, where you only have to write a function, right? And then you just return the result. But that's not true in competitive programming. For competitive programming, you always want to write a complete program so that once you compile it and run it, you can just run it directly without having to write extra code. So just as a summary, first, when you see a problem, you read the problem statement, the output specs, and the sample test case. Work through the sample test cases, and then step 2, you code up a solution, and then finally submit your solution to receive a result. Okay.
Hello, if you guys didn't catch my name, I'm Robert, and I'm going to go through the rest of these example problems. So in the example contest, we have 2 more problems, B and C, and we're going to be working through them together. All right, so problem B is called Faktor. I will give you guys a few minutes to read through the problem statement, right? That's the first step that we do for any problem. And yeah, so just please read through the problem statement. All right, I hope everyone was able to read through the statement. I'll just do a quick TLDR. So basically, you have a journal that you're publishing, and in the journal there are a bunch of articles. And to grade like how good this journal is, it depends on the number of citations this journal has received, or received by the articles published in the journals. So to kind of rate a journal, you get the total number of citations, you divide it by the number of articles in the entire journal, and then you round it up, no matter what number it is. So the example, right, there's 894 citations, but there's 33 articles, so we divide it and then we round up to 24. So as always, when we're doing these problems, there's 3 steps that we need to follow, right? And we just go down the problem that we have. So we read the problem statement, which we just did. We read the input and output description, because sometimes for certain problems, they want you to take in the input a certain way, they'll give you some information you might have to infer yourself. And then output also, like what type of information are they looking for and in what format. And then finally, for this problem, we have 3 sample cases that they've graciously given us, and we can see the proper output for the input. And these can also be like a sanity check for your code. So once you're done programming, you can test against these sample cases that they gave you. Okay. Also, just as a tip, instead of including a bunch of imports at the top of your, importing a lot of different libraries at the top of your program, you can just do this one line, include bit/std c++.h, which imports all the major libraries, the major standard libraries for C++. So stuff like vectors, stuff like queues, stacks, anything that you'll possibly need that'll make your life easier. And like basic stuff like input and output. So we're gonna work through this problem now. So here's some hints for how we can approach this problem. So if we look at the third sample, we're given 10 and 10 as the input. So that means if we read the problem statement, that means that we get 10 articles and we want to reach an impact factor of 10. And we want to figure out the minimum number of citations that we need in this journal to reach that impact factor of 10. And we can see that this is the case because if we kind of reverse engineer this problem and we do it backwards, so we get 91, we divide it by the number of articles, so we get 9.1, and then we can round that up and that gets our desired target of 10. And we can see that this is the minimum number of citations because if we get one less citation, we get 90 divided by 10, which is 9, and we can't round that up. So now if we look at sample number 1, we can see that we have much larger numbers and like it's not as clean of an answer. So does anyone think that they can explain how they got the answer for sample output 1? Anyone want to try explaining the answer? Okay, so what's your name? Kevin. So Kevin said to get our answer for the sample output 1, we multiply the 2 numbers together, so 38 times 24, and then we subtract the first number, which is 38, and then we add 1. And then, so in this case, that kind of algorithm or that formula works for us. So for this problem, the solution, we can kind of write out for like another sample case and see how we can reach that solution. So for example, if there are 3 articles and we want to reach an impact factor of 6, we can see how the impact factor changes as we include more and more citations. So if we only add 1 citation to this journal, it will automatically go from an impact factor of 0 all the way to 1. So just by adding 1 citation, we go up by 1. However, if we add 2 more to go to 3 citations, it still stays at an impact factor of 1. And only when we add 1 more will it go up again. So you can kind of see that there's like, we can get like a free addition of impact factor sometimes when we cross over some threshold of number of citations. And we can see as we keep going up all the way to 5, once we get 1 more than 15 to get to 16 citations, then we reach our targeted impact factor of 6. So if we want to write it in terms of like a formula, we can see that if we let n be the number of citations, x be the target factor we want, and a be the number of articles there are, we can kind of write up a nice formula to calculate this. And this is very, very similar to what Kevin said, right? Where we multiply the number, our target impact factor by the number of articles, and then we subtract. So this is factored out here. We subtract the number of articles, and then we add 1. And we can see this works because if we remove just one citation, the target impact factor that we get is going to go down by 1, and it's going to be x minus 1. So we can kind of prove that this is going to be the minimum answer, or the minimum citations that we need. Does anyone have any questions? All right, we'll give you guys a few minutes to try and make your own submission, and see if you can get answer correct as well. And we'll have officers walk around. Please flag them down if you need help with anything, submitting or writing the program or debugging. Just implement that one. See it. Just walk around. It's fine.
But you do have
All right, if you guys have solved the problem, feel free to move on to the next one and start reading the problem statement.
So if you get input, so like, so you ask like, what's the format out there? And that gives you the entire. Yeah, you can do it. But yeah, that should work.
Does anyone need more time? All right, we're gonna move on to the next question then. So the next question is called boss battle, and it has to do with kind of a game that's set up where you're trying to defeat a boss. And how it works is that there's a bunch of pillars in a circle, and the boss can hide behind one of those pillars. So you don't know where the boss is. And what you can do is you can put a bomb out of a pillar, and what it does, if the boss is behind that pillar that you put the bomb in front, or any of the adjacent pillars, then the boss will die. And you want to figure out how to guarantee defeating the boss with the least number of bombs. So this repeats in multiple turns. So the boss hides, then you place the bomb, it explodes, and the boss can move to one of the adjacent pillars. So as always, right, we want to work through the sample cases that they gave us, right? So the second sample case might be a little hard because it's a larger number, but we can try with like only 4 pillars and 5 pillars and see how is it possible. So you need to both think as the player and also as the boss. How would the boss move so that the boss could survive the most number of rounds and so on. Okay, so the big idea with this question is to think about pillars as like having 2 categories. So either the boss can't possibly be here, we've already checked it, or the boss could be here, right? Those are the 2 cases. So we can see on the first round, so we will let K be the number of rounds. So let's say there are 6 pillars. So on the first round, if we place the bomb here, right, it'll blow up. The boss can't possibly be in any of these 3 locations, right? But then once the bombs blow up, the boss can move. If it was here or is here, it can move into these spots. And then that means that the boss can't possibly be behind this pillar. Then on the next round, if you're smart, you can place the bomb here, and you can knock out these possible options. So then, on the boss's turn, the boss can only move to these 2, and there's 2 possible places that the boss can't be. So you can think about it as each turn, right? We get rid of 3 possible places that the boss can be, and then the subsequent turn, the boss can only be in 2 more, hide behind 2 other pillars. So it's like we're slowly creeping up on the boss. And we can continue this kind of a circular kind of shape until we eventually catch up to the boss. So you can see for 6, we just keep going in a circle, and then eventually we'll get to a point where the boss can't be in these 3 pillars, and there are 3 pillars that we can blow up. And there's no way for the boss to survive. Then we win. So this can be done with only 4 bombs. So we can kind of also graph this out. So we can see that the number of positions eliminated, the number of positions that the boss can be in, or can't be in, increases every time we drop a bomb by 3. And then it decreases by 2 every time the boss gets to go and then move to a different pillar. And then you can see as this number increases, as the number of turns increase. So at a certain point, we'll definitely clear the game and defeat the boss, no matter how many pillars there are, which seems pretty unintuitive, but if you look at it in this perspective, you can kind of see how that works. So a lot of problem solving is kind of refactoring the question and thinking about it from a different perspective to see, to kind of make more sense of it. Finally, we can concisely capture everything that we were just talking about into just a simple formula where it's just if there's more than 2 pillars, right? It's going to take 2 less turns than the number of pillars to beat the game. However, if there's only 1 pillar or 2 pillars, and we know we can beat it on 1 turn, right? We don't need to chase the boss. All right, we'll give you a few more minutes to try and submit this solution and hopefully get it right. Not. It's a graph, but you don't need to think of it as a graph too much because it's just a circle. But you can kind of think of it as that. It's like chasing. But normally for graph theory, you kind of think about more along like distances or like how things are connected. But for this one, it's just it's just planar theory. I see. That's all right. I did not think that. All right, it's almost the top of the hour. So, I have a few more tips for you for solving these problems. Before submitting to Kattis for them to judge your program, always test your code locally on the sample case that you have or any sample cases you can come up with. And this just makes it so it's easier to debug because the judge isn't that nice. It doesn't tell you what went wrong. It just tells you you're wrong. Same thing, work through the samples and also kind of write out. So these problems are a little easier, so you can kind of keep them in your head. But some things, there's a lot of moving parts. So it's nice to write things down. And please come to the next session where we'll do more problems and start introducing new topics. No, there's gonna be there'll be more for the last hour. Yeah. Okay, so if you have any questions, comments, or concerns about how we taught this workshop or how we ran it, feel free to reach out to us and let us know. And then finally, we have the contest for this workshop that you guys can work through and see if you can solve together. So you guys can get to this different contest here through this tiny URL link. So there will be 5 problems, and us officers will be strolling around. So feel free to flag us down, and we can help you work through problems, debug, anything you need. We're happy to help. Thank you for coming.